In 1954, a group of unknown aircraft designers presented an airplane that was to revolutionize Soviet aviation. In a couple of years, it would turn into the world's first supersonic aircraft to conduct strategic reconnaissance deep inside enemy territory. It would have enormous speed and elements of stealth design. So the Soviets were the first to have the SR-71? While distinguished design bureaus competed to exceed twice the speed of sound, their airplane was to obtain unbelievable 3,000 km per hour, to climb 30 km, and its range was to equal 14,000 km. Its sophisticated design puzzled the leaders of existing Soviet design bureaus who had already divided up the spheres of influence by the end of the 1940s and tolerated no competitors. Technical proposal presented by the head of the group named Pavel Tsybin was so daring that the military and political leadership could not but support it. Preliminary offer was to create a high-speed delivery vehicle for nuclear weapons, or as it was called, special cargo. Its parameters had no alternative, since the ballistic missiles were still under construction, and existing bombers were mostly subsonic. Furthermore, Tsybin managed to get his own design bureau together with aircraft building factory number 256. It was incredible impudence, especially to Tupolev, whose primacy in creating strategic bombers could have been attacked. That was unforgivable. If you enjoyed the video and you want to support the channel, hit like and subscribe with notifications. Your comments will also be a great help to promote the video. I invite you to join my YouTube journey. More videos ahead. Glad if you enjoyed. The resolution to arrange the design bureau number 256 and to build an aircraft under the code name RS, or Reaktivny Samolot, which stands for jet airplane, was signed by the first 13 leaders of the Politburo and the government of the USSR. Malenkov, Khrushchev, Kaganovich, Mikoyan and others had signed the document. Incredible support. What could possibly go wrong? Actually, almost everything. Tsybin needed the best aviation professionals to bring the ideas to life. Although in the late 1940s, lots of small design bureaus, including his own, were closed, the best specialists were shared by the leading companies that were left. Moreover, Masishev, who also presented revolutionary ideas in strategic bombers development, and received his design bureau a few years ago, had to collect the remaining personnel. Despite that all the main design bureaus were obligated to provide experts, their leadership tried to get rid of the low-skilled and unwanted. Tsybin also had to hire lots of distributed university graduates, who can hardly be called professionals. The lack of coordination between different departments resulted in the development of 5 aircraft concepts. All of them were equal and signed by the chief designer. It was impossible to imagine that this confusion would save the whole bureau in the future. A government decree of 1955 stated that Tsybin was given 2 years to build an airplane. Given the tight timelines, the work should have started immediately. No way, it was in the USSR. Since it was declared that an aircraft's weight efficiency would equal unbelievable 80%, a special subcommittee was created to test this. Their conclusion was that the value could not be higher than 60%, which also was a great result. So the work was to begin? No. Various audits and commissions lasted for about a year, distracting designers from their work. When nothing was left to inspect, the work began in its full force, and the real trouble started. First of all, the initial design of the aircraft was too sophisticated. The special cargo actually was the plane's tail section, equipped with its own wings. The RS was to drop at 50 km from the target, so the cargo would fly towards it, while the rest of the plane would return to the base without a tail unit. Front stabilizers were supposed to play its role on the way back. Both the airplane and cargo were entirely self-sufficient. It took some time for the engineers to understand that it was not technically feasible. The project was changed into a conventional airplane, and the special cargo was located under its fuselage. Another small problem was that an engine which was to provide aircraft's 80% weight efficiency did not exist. However, neither authorities nor inspectors seemed to care about it. An official order for the development of the RD-013 supersonic jet engine was sent to the Bondaruk Design Bureau. With a traction of 4,400 to 4,500 kgs, a pair of such engines would provide a speed of 3,000 km per hour at high altitude, but the range would exceed only 7,500 km. It was almost a half of maximum range that was declared. This brought another innovative idea. The RS was to be hung up under the Tupolev TU-95N Carrier aircraft. The TU-95N was to carry it at a distance of 3,000 to 4,000 km. Later, RS would be detached and accelerated by two coupled liquid propellant rocket engines until it reached cruising altitude. After it, airplane jet engines would provide the speed of 3,000 km per hour. It was too much for Tupolev. He had to participate in the competitor's project as an additional link. Tupolev was the patriarch of the Soviet aviation industry, but he had to obey government's decree. He could not hide his contempt for the project and its creators. During the presentation, Tupolev stated that if he would find out how they were going to realize it, he would make it much better and faster. What is more, the failure would prove that they were not worthy to have their own design bureau. Tupolev would play his role in the later fate of the project, but now he, as well as many others in the aircraft industry, had to save his own design bureau. Several years after the death of Stalin, Khrushchev managed to concentrate all the power in his hands. He tried to destroy everything related to the previous chief. Stalin adored aviation, and to oppose his saying that Soviet aircraft would fly highest of all, farthest of all, and quickest of all, Khrushchev stated that a rocket would replace an airplane. The rocket designers managed to convince him and other leaders that the missiles could completely supersede the aviation. The success of Korolev in creating and testing ballistic missiles and a series of space achievements only proved them right. Khrushchev started total aviation contraction. Lots of existing airplanes were destroyed. Aircraft factories were redirected to rocket construction. The RS project was closed as special cargo was now rocket carrying. Tupolev Design Bureau terminated work on the Tu-95N unilaterally. This could be the end, but the crisis gave birth to an aircraft which had no analogues in the USSR. Remember those 5 concepts signed by the chief designer. One of them was a concept of a strategic reconnaissance aircraft, an airplane which was to become Soviet SR-71 Blackbird. This project was the one that saved Tsybin Design Bureau. Spy satellites were far from development, and the airplane's high altitude and speed left no alternative. The project, named the RSR, Reaktivny Samolot Razvedchik, or reconnaissance jet airplane, took little from its RS predecessor, mostly its unusual aerodynamic layout. The machine had elongated body and small trapezoidal wings. Its length equaled 28 meters, and the wingspan was 10.66 meters. The engines were located on the wing ends. The air launch was now impossible. More powerful jet engines were needed for an airfield takeoff. The chassis was also modified, as the previous variant was designed only for landing. The airplane still had a bicycle landing gear, although it was redesigned from 2-wheeled to 4-wheeled, considering the length growth. The first operational aircraft was to be ready by the first quarter of 1958. New design agreed with the Air Force had more modest parameters. The power plant included 2 D-21 Solovyov engines. The RSR was to climb 20 km in 15 minutes after separation from the runway and reach the speed of sound at an altitude of 8.5 km 4 minutes after the takeoff. At an altitude of 10.7 km, at a speed of 1,540 km per hour, the pilot would drop suspended supersonic tanks and perform a long stationary flight at a cruising altitude of 25.5 km with a speed of Mach 2.85. Yet the range decreased to 4,000 km. The project, completed on June 26, 1957, was excellently made. so the government commission confirmed the validity of its performance at once. The most daring hopes of the Kremlin began to come true. They would receive the first supersonic aircraft in the world to conduct reconnaissance at a distance of 1,700 kilometers from the airfield. During the flight, the reconnaissance aircraft had to observe radio and radar silence. In order to reduce radar reflection, the designers applied relevant shapes to the lower surfaces and investigated the possibility of using radio-absorbing materials. The RSR systems were creating active and passive radio interference in the operational frequency range of an air defense detection. The cabin was pressurized, so the pilot was wearing a spacesuit. The air temperature outside the cabin was changing from -60 to +60 degrees Celsius, or from 140 to -76 degrees Fahrenheit. Yet in the cabin it did not exceed +30 to -5 degrees Celsius or 86 to 23 degrees Fahrenheit. Individual air conditioning system was connected to the spacesuit. In the case of emergency, the suit was also pressurized to provide acceptable living conditions so the pilot could descend into the denser atmosphere and return to the airfield. It became increasingly apparent to the designers that they needed a full-scale model to do in-depth research of its takeoff, landing, air behavior, and other specific characteristics. They managed to build it despite the lack of estimate funds and government regulations. The NM1 had similar outlines, but it was smaller and subsonic. D-21 engines were still in development. Control system as well as airframe design had no fundamental differences from the RSR. However, the chassis was completely different. Lightweight ski made of a 10 mm derailment plate was introduced for landing. It was to be equipped with two-wheeled trolley for takeoff. After several landings, the ski would be replaced with a new one. Its maiden flight occurred in April 1959. From 1959 to 1960, the NM1 aircraft was used by 10 test pilots to carry out 32 flights lasting from 11 to 40 minutes at altitudes of 1,000 to 4,000 meters. The aviation ministry officials considered its wing configuration the most arguable part. The test proved that an airplane with such a wing not only could fly, but it had a very good volatility in flight and on landing. Furthermore, it performed commands efficiently, starting from the speed of 60 km per hour. The NM1 aircraft's controllability during takeoff and landing was much superior to those of Su-7, Su-9, MiG-19 and MiG-21. All the blueprints of the RSR were ready by 1959. The building process was ready to start, but D-21 engines were not supplied in either 1958 or 1959. The factory that was to produce D-21 also made D-20 engines for Tupolev's Tu-124 passenger airplane. By 1959, the authority of Tupolev was incredibly high. His first jet passenger aircraft, Tu-104, and a VIP airliner Tu-114, which was made specially for Khrushchev's visit to the USA and was a passenger version of the Tu-95 bomber, made him the main aircraft designer in the USSR. Tupolev opposed the production of the D-21 engine, same as all the attempts of the officials to renew the TU-95N Carrier project. Now his refusal was justified. His airplanes were serial, unlike Tsybin's concept. On May 15, 1958, the meeting of experimental aircraft engineering was held in Kremlin. Tupolev recommended that Mesichev should connect with Tsybin to provide an aircraft carrier for the RSR project. It was the first step to get rid of the competitors who dared to encroach on his niche. Both Mesichev and Tsybin were distracted from their work. No one actually cared that RSR blueprints were ready to make a production model with ground takeoff and landing. Tsybin was desperate and made an unexpected move. He appealed to the leadership of the Politburo, the command of the Air Force, and TSAGI, main aviation science center of the USSR. It was unacceptable to appeal directly to the highest rank officials, but the extraordinary move that he made earned him support. His funding was increased, and the deadline was extended until the end of 1960. To speed up the work, new engines R11F by Tumansky were to be introduced. Since they were outfitted in the MiG-21F aircraft, the chief designer Mikoyan was tasked to help with the implementation of a new propulsion system. The main and last variant of the RSR received two engine gondolas with a central column that resembled the nose of the MiG-21 fighter. Newer and more sophisticated photo equipment was installed in the pressurized cabin with a larger window. Two cameras were mounted on one platform which would be taken to the lab after the mission. The airplane had to be as light as possible to fit previously announced parameters with the new power plant. Welding was used more often than rivets. Electrical wiring and other communication elements, including plugs, were almost half the size. The construction went quicker as lighter elements were much easier to mount. The airframe was reinforced only in critical areas. The most effective means of reducing weight of the RSR was the refusal of supersonic suspension tanks. The calculations showed that much lighter tanks could be dropped at subsonic speed. This would decrease the airplane's takeoff weight without the range reduction. This innovation, same as most of Tsybin young designer's progressive ideas, was rejected by the older and conservative officials of the Ministry of Aviation Industry. The construction of the first airplane was begun at the factory number 256. Yet the work was not finished, as the factory, along with the design bureau, was transferred to deputy chief designer of Mikoyan named Bereznyk. It was to develop unmanned aircraft, but in fact it produced spare parts and subassembles for MiG-21. On the 1st of October 1959, the Tsybin Design Bureau with all the staff and documentation was included in the Messishev Design Bureau. Messishev was focused on the development of the M4 and M6 strategic bombers, so Tsybin's designers continued the assembly and preparation for flight tests. On September 29, 1960, the first RSR aircraft was taken to the test airfield. At the same time, the factory in Ulan-Ude started the RSR serial production. In October 1960, Messishev was dismissed from his post as a chief designer and transferred to the head of the Tsagi. All the staff was fully reassigned to a rocket building design bureau number 52 with the chief designer Chelomey as a leader. In 1961, the work on the project RSR was stopped. Tsybin and his designers were instructed to transfer all the documentation to a new leadership. Unfortunately, most of it was destroyed because it had nothing to do with the missile industry. By 1961, the Ulan-Ude factory built 3 RSR airplanes, and 10 more were assembled except for the engines, which were not supplied, when the command to cut the aircraft for scrap came. It was unbelievable for Soviet reality, but the workers refused to scrap the airplanes they had just constructed. In order to avoid a scandal, the factory management decided to transfer all the airplanes to long-term storage, where they were dismantled a few years later. The NM-1 and the RSR test airplanes were disassembled and taken to aviation institutes as teaching aids. Tupolev managed to get rid of his both competitors, Messishev and Tsybin, whose innovative ideas could be a threat to his authority as a leading designer. Yet it was not him who brought Tsybin Design Bureau to destruction. Another prominent designer, Mikoyan, promised to Soviet leadership to create Mach 3 capable reconnaissance airplane under the code name 155. He had the entire MiG team of professionals, the R-15B engine, and the photo equipment created for RSR installed and tested on it. However, he was not lucky. Mach 3 flight speed was not achievable. At the end of the 1960s, they were able to reach the speed of Mach 2.85, but Tsybin had already proposed this in 1956. They also failed to reach the range of flight which was planned for the RSR, and the MiG-25R became a tactical reconnaissance instead of a strategic one. In the late 1960s, while working as a deputy chief designer of Korolev, Pavel Tsybin finally managed to build his reconnaissance aircraft. The experience he acquired in the creation of the RSR was utilized in the design of the first Soviet reconnaissance satellite named Zenit, which was put in service in 1964. Strategic reconnaissance airplanes were no longer needed. Russian 1990s researchers claimed that the concept of the RSR was used during the SR-71 creation, yet I was not lucky to find any proof of these statements. Maybe you will.